We can also encounter problems where we're given an algebraic expression, something like x squared, where x represents some unknown value or a value that we'll make a substitution for. For instance, in these problems, in example 13, we'll be asked to evaluate the expression below when x is equal to -5. That means we want to take that given expression, x squared, and everywhere an x occurs, we want to substitute in -5. I'll let you know that I always like to substitute values by putting them inside a set of parentheses. It just helps me catch things like double negatives, whether the negative is being raised to the second power or not. It just kind of helps to keep track of and avoid some small arithmetic errors here and there. So in this case, we're substituting in -5 for x, and that value squared means we're going to take -5 times -5. So a negative times a negative will end up being positive 25. We'll get a slightly different result in part B, where we have -x squared, or the opposite of x squared. Again, I'm going to make that substitution in a set of parentheses, which helps me keep those two negative signs sort of separated from each other, keeps my problem a little clearer. Whenever we have an exponent only applies to whatever it's directly next to. So in this case, all we're doing is squaring the -5. That original negative that was in the original problem that was given to us isn't impacted by that square. So this will be -5 times -5, which is a negative times a negative. So we're going to get negative positive 25. So the -5 times -5 gives us positive 25. But we still had this original negative sign that's going to carry with us, which will leave us with -25 as that final answer. In example 14, we want to do the same thing, except now we're substituting x equals 4 into these two expressions. In the first case, we're going to substitute in 4 and then have that value raised to the second power, which will give us 4 times 4, or 16. That's a slightly different expression than what we have in part B. Instead of x being raised to the second power, now we have 2 being raised to the x power, so we're going to substitute that 4 in to the exponent. 2 to the 4th power is the same thing as 2 times 2 times 2 times 2, which will be 16. In this case, we do end up with the same value, which is a bit more of a coincidence. It is important to notice that we have two different expressions, whether the variable is being raised to an exponent or we have a number being raised to a variable exponent. Then in example 15, we're asked to do the same thing for x equals 3 with the expression -5x squared plus 8x minus 1. Again, I'll substitute 3 in for x everywhere it occurs in the original expression. And I'll do that in a set of parentheses to help keep track and separate any negatives and things like that that we might run into. So everywhere an x occurs in the problem, I've substituted that in, so that we now have -5 times 3 squared plus 8 times 3 minus 1. Again, keep in mind that the exponent only applies to whatever it's directly next to. So the only thing that's being squared in that first term is the 3. Following order of operations, we'll first look for anything inside parentheses. We did substitute the 3 inside parentheses, but there's nothing else to simplify there. It's just 3. So we'll evaluate -5 we'll have negative 5, and then we'll evaluate 3 squared, which will be 9, plus 8 times 3 minus 1. Then next we'll take care of any multiplication and division steps. Negative 5 times 9 will give us negative 45, plus 8 times 3 will give us 24, minus 1. And then in our last step, we'll take care of addition from left to right. Negative 45 plus 24 minus 1 will give us negative 22.